This section will introduce basic ideas on data annotation and tools, and how to measure as well as control data quality. Data annotation is necessary to build machine learning models, especially for supervised learning models in different applications, such as image processing, natural language processing, and smart grids. This figure shows the general flow of data annotation. The first step is to collect raw data from different sources. Then we have to construct a team with different expertise, especially domain experts for the applications. Prior to data annotation, the team has to work together to complete annotation guidelines. Finally, with these guidelines, the team will complete data annotations on the raw data and evaluate the annotation results. First example of data annotation based on image processing. These three figures represent the annotation for image classification, object detection, and semantic segmentation, respectively. For instance, cat is the label for the first image. There are many tools for image processing. For example, Label Me is a tool to annotate images for image segmentation. Some features of this tool are image annotation for polygon, rectangle, circle, line, and point, image flag annotation for classification and cleaning, video annotation, GUI customization, predefined labels, flags, auto-saving, label validation, etc. It also exports VOC format dataset for semantic or instant segmentation, and also exports COCO format dataset for instant segmentation. CVAT is a free online interactive video and image annotation tool for computer vision. It is being used to annotate millions of objects with different properties. Many UI and UX decisions are based on feedbacks from professional data annotation teams. In addition, there is a sample annotation tool for instant vision object detection. It is an open source software and easy to use. It can be used to change image size and labels. Natural language processing is another application that requires substantial annotated data to build different applications. There are two examples of NLP tasks. One, semantic analysis, which is a natural language processing technique used to determine whether data is positive, negative, or neutral. It is often performed on textual data to help businesses monitor brand and product sentiment in customer feedback and understand customer needs. 2. Named entity recognition, which is a subtask of information extraction that seeks to locate and classify named entities mentioned in unstructured text into predefined categories such as person, organizations, time expressions, quantities, etc. These two tasks need label data shown with these two figures respectively. After completing data annotation, then the annotation quality is evaluated. This is achieved through the following steps: calculating the accuracy of an annotator compared to ground truth data, calculating the overall agreement and reliability of a dataset, measuring inter-annotator agreement on a per-task basis to generate a confidence score for each training data level, designing architectures that incorporate subject matter experts into the annotation workflow, breaking up a task into simpler subtasks to improve accuracy, efficiency, and quality control. Data quality refers to the state of qualitative and quantitative pieces of information. Data is of high quality if it is fit for use in their intended operational, decision-making, and other roles. There are some quality properties which includes relevance. Several facets are important to the relevance of the data analysis use of data. Does the data meet the basic needs for which they were collected, placed in a database, and used? Accuracy. Which customers will buy certain products in a grocery store? Which customers bought products? 1. This week, 2. 12 months ago, and 3. 24 months ago. Timeliness. How current do public opinion polls need to be to accurately predict election results? Comparability. Can several databases be combined into a data warehouse? Is it appropriate to combine several databases into a data warehouse to facilitate the data's use in 1. Exploratory analysis, 2. Modeling, or 3. Statistical estimation? Completeness. No missing record, no missing data element. In the survey sampling literature, entire missing records are known as unit non-response, and missing items are referred to as item non-response. Both unit non-response and item non-response can indicate lack of quality. In many databases, such as financial databases, missing entire records can have disastrous consequences. When such problems arise, the processes that create the database must be examined to determine whether 1. Certain individuals need additional training in use of the software, 2. The software is not sufficiently user-friendly and responsive, or 3. Certain procedures for updating the database are insufficient or in error. Reasons to control data quality are presented on this slide. High-quality data can be a major business asset, a unique source of competitive advantage. Poor data quality can lower customer satisfaction. Poor data quality can lower employee job satisfaction too, leading to excessive turnover and the resulting loss of key process knowledge. Poor data quality can also breed organizational mistrust and make it hard to mount efforts that lead to needed improvement. An example of what the data quality should be for an application. Insurance companies need accurate and complete databases in order to accomplish mandated accounting tasks, compute insurance in force, compute claim rates, calculate premiums, and construct models to predict future results. The following processes is used to ensure that high-quality data is obtained. 1. Prevention. Ensure that all data entering the database or list are of high quality. 2. Detection. The data analyst needs to proactively look for data quality problems and then correct the problems. 3. Repair. The worst approach is to wait for data quality problems to surface on their own. 4. Allocating resources. The question arises as to how best to allocate the limited resources available for a sample survey and an analytical study. The typical mix of resources devoted to these 3 activities in the United States tend to be on the order of prevent 10%, detect 30%, and repair 60%. Strongly suggest that a more cost-effective strategy is to devote a larger proportion of the available resources to preventing bad data from getting into the system and less to detecting and repairing, that is, correcting erroneous data. It is usually less expensive to find and correct errors early in the process than it is in the later stages. A much better mix of resources would be prevent 45%, detect 30%, and repair 25%. Thank you.